It's the longest sea bridge in the world, 55 kilometres in total, and it's ready for its premiere.
It's 55 kilometres long, 6 lanes wide, with 4 tunnels and 4 artificial islands.
What happens when a country decides to drill through the ocean floor at speeds that break every record on the planet? What kind of machine do you need to carve through rock 78 meters below the sea, where one wrong calculation could flood an entire tunnel and end thousands of lives? China just answered those questions with a project so massive, so technically insane, that even engineers from other countries are scratching their heads, wondering how it's even possible. This isn't about building another bridge or highway. This is about rewriting the rules of what humans can achieve beneath the waves. And if you think you've seen impressive construction before, wait until you hear what's happening right now under the East China Sea.
Let's talk about what's happening in the South China Sea, where tensions are escalating yet again.
Stay with us to uncover the shocking truth behind this story. The foundation of a giant. Let's rewind for a moment and look at how China rose to become the construction powerhouse of the world. There's an old Chinese saying that goes, "If you want your country to prosper, start by building roads." Simple, almost poetic. But beneath that simplicity lies the blueprint of China's modern miracle. Because roads don't just connect cities, they connect destinies. Without infrastructure, you can't move people, you can't move goods, and you certainly can't move a nation forward. China understood this better than anyone. In the late 20th century, the country was still recovering from decades of hardship, its cities crowded and its countryside disconnected. But instead of patching what was broken, China decided to rebuild from the ground up. Highways sliced through mountains, railways stretched across deserts, and bridges leaped across rivers once thought impossible to span. The nation turned construction into a form of national identity, a symbol of determination.
This gigantic structure hangs in midair between 2 mountains, 625 meters above the river below. China has now officially opened the highest bridge in the world.
Unity and sheer ambition. Over the past few decades, China has gone from playing catch-up to setting the global standard. They built the world's longest bridges, tallest dams, and most extensive high-speed rail networks, all in record time. Projects that would take other countries decades, China completed in years. It wasn't just speed, it was precision, discipline, and an unshakable belief in progress. The cranes never stopped moving, the concrete never stopped pouring, and the skyline never stopped rising. China didn't just build infrastructure, it built the future, one beam and one brick at a time. Take high-speed rail, for example. In just 10 years, China built and opened 45,000 kilometers of high-speed train lines. To put that in perspective, Japan and Europe took almost 3 times longer to develop their networks. And even then, their combined length doesn't come close to what China has now. Today, China operates more high-speed rail than the rest of the world combined. And the technology didn't just get imported from other countries. Chinese engineers took what existed, improved it, and pushed it into what they're now calling the high-speed rail 4.0 era. That's not just catching up, that's taking the lead. Then there's the Three Gorges Dam, the biggest and most complicated hydropower project ever built, or the South to North Water Diversion Project, which moves water across distances and terrain that would make most engineers give up before they even started. These aren't just construction projects, they're statements. They say, we can do what others think is impossible. But among all these giant projects, there's one category that stands out as especially difficult, especially dangerous, and especially impressive. And that's the work China is doing with bridges and tunnels that connect islands to the mainland. This isn't just about convenience, it's about linking isolated communities, creating new economic zones, and proving that geography doesn't have to be a limitation anymore. The transformation has been remarkable. Islands that were once accessible only by boat can now be reached by car or train in minutes. Fishing villages have turned into industrial hubs. Remote coastal areas have become vital parts of the national economy. When bridges become legends, from above, The view is almost unreal. You're looking at a chain of massive bridges stretching across the ocean,
The world's tallest bridge opens to traffic in Guizhou in China.
connecting islands that used to be cut off from the rest of the country. These aren't small bridges. We're talking about structures with main spans over a kilometer long, built to withstand typhoons, earthquakes, and the constant pounding of ocean waves. The Shihumen Bridge is a perfect example. Its main span stretches 1,650 meters across the sea in one single leap. For 10 years, it held the title of China's longest span bridge. But it's not alone. Nearby, you'll find the Jintang Bridge, the Taoyaomen Bridge, the Xiangjiaomen Bridge, and the Chenggang Bridge. Together, they form a nearly 50-kilometer chain that ties once isolated islands into one connected system. Building these bridges wasn't easy. Each one required years of planning, thousands of workers, and solutions to problems that had never been solved before. How do you build bridge foundations in water that's dozens of meters deep? How do you design a structure that can flex in an earthquake without collapsing? How do you protect steel and concrete from the corrosive effects of salt water over decades? Chinese engineers found answers to all of these questions. They developed new materials that resist corrosion better. They created construction techniques that allow them to build in deeper water than ever before. They designed bridge structures that can move and flex without breaking. And they did all of this while building at a pace that other countries couldn't match. Then came the Yushan Bridge, spanning 8 kilometers to link Yushan Island with Daishan Island. A dozen years later, the Zhoushan-Daishan Bridge appeared, stretching 25 kilometers to connect Daishan Island to the main island of Zhoushan. Add in the 32.5-kilometer Donghai Bridge, which links Shanghai to Xiaoyangshan Island, and you start to see a pattern. China isn't just building bridges, it's building networks, it's creating new geography, and the results speak for themselves. Because of these bridges, China now has the busiest cargo port in the world. It has one of the largest offshore petrochemical bases, and it has better access to some of the richest fishing grounds in the region. All of this came from construction projects that most countries wouldn't even consider attempting. The economic impact has been massive. Islands that were once economically isolated are now thriving. Property values have increased. New businesses have opened. Young people who left for opportunities in big cities are coming back because opportunities now exist at home. The bridges didn't just connect land, they connected futures. Digging through the ocean floor. Bridges are impressive, but they have limits. Sometimes the distance is too far. Sometimes the weather is too harsh. Sometimes you need something more direct, more protected, more permanent. That's where undersea tunnels come in. And this is where things get really interesting. Right now, China is building what will become the longest undersea high-speed rail tunnel in the world. It's called the Jintang Undersea Tunnel, and the numbers alone are enough to make your head spin.
A mega project is underway to build a tunnel under the Baltic, linking the country.
The total length is 16.18 kilometers. Of that, 11.21 kilometers run beneath the seabed. The tunnel is 14.5 meters in diameter, which is about as tall as a 5-story building. And it's designed to carry high-speed trains traveling at 250 kilometers per hour. Let that sink in for a moment. Most undersea tunnels in the world are built for slower traffic. The famous Channel Tunnel between Britain and France, trains go through at around 160 kilometers per hour. Japan's Seikan Tunnel, about 140 kilometers per hour. The Jintang Tunnel is designed for speeds that blow both of those out of the water, and it's longer and deeper and more complex. So how do you even build something like this? You need machines, big machines, the kind of machines that look like something out of a science fiction movie. Enter the shield tunneling machines. These are massive rotating cutting heads mounted on enormous mechanical bodies that inch their way through rock and soil, carving out tunnels as they go. For the Jintang project, 2 of these monsters are being used. One is called Dinghai, and the other is called Yongzhou. Each one has a cutter head nearly 15 meters across, covered in steel blades that slice through layers of earth like a knife through butter. But here's the challenge. These machines aren't just digging through dirt. They're working 78 meters below sea level, where the water pressure is immense. They're cutting through 28 different geological layers, some solid rock, some soft soil, all mixed together in unpredictable ways. And they're doing all of this while being guided by China's Beidou satellite navigation system.
What do you know about the Beidou navigation satellite system?
Which keeps them on course with millimeter-level precision. The engineering challenges are staggering. When you're digging through solid rock, the cutter head needs to be incredibly strong and the machine needs massive power to push forward. But when you hit soft soil, especially the sticky clay found in some areas, the machine can get bogged down. The soil clogs the cutting head. Progress slows to a crawl, so engineers had to modify the machines, adding water injection systems that help flush away sticky material and keep the cutter head clean. Then, there's the pressure problem. At 78 meters below sea level, the water pressure is enormous. If the seal around the shield machine fails, water comes rushing in with catastrophic force. So the machines need multiple layers of sealing systems, all designed to handle extreme pressure for extended periods. The plan is for the two machines to start from opposite ends and dig toward each other. Yongzhou digs 4,940 meters from the Ningbo side. Dinghai digs 6,270 meters from the Zhoushan side, and eventually, deep under the ocean, they meet. But they can't just meet anywhere. They have to meet in exactly the right spot, with an alignment error of no more than 2 centimeters. That's why the engineers chose the meeting point carefully. It's in a stable rock formation, the only place where they could be sure the junction would hold. And to make absolutely sure they didn't mess up, they used 6 Beidou satellites linked to the shield machine's navigation systems, correcting course in real time as they dug. Think about what that means. These machines are crawling through solid rock, dozens of meters below the ocean floor, and they're being steered by satellites in space. The margin for error is basically zero. A miscalculation of even a few degrees at the start could result in the two tunnels being meters apart when they're supposed to meet. And then there's the final problem. When the two machines finally meet, they can't just turn around and drive back out. There's no room. So the engineers came up with a solution they call shedding the shell. The machines get dismantled piece by piece and hauled out through the tunnel they just created. But the massive steel outer shells stay behind, permanently reinforcing the tunnel structure. If everything goes according to plan, the tunnel will be fully dug through by the end of 2026, and trains will start running through it in 2028. Once it's open, people will be able to travel from Ningbo to Zhoushan in just 30 minutes by high-speed train. That's a game changer for the islands, which have never had rail access before. But there's something else going on here that nobody's saying out loud. This tunnel isn't just about connecting Zhoushan. Many people believe it's actually a test run for something much bigger, something that's been talked about for years but never seriously attempted. We're talking about a tunnel across the Taiwan Strait. If China ever decides to build that, the Jintang Tunnel will have been the rehearsal, the proof of concept, the place where they figured out how to do the impossible, building beneath the waves. Now, if you're wondering just how far China has come in undersea tunnel technology, let's look at another example. The Hong Kong-Zhuhai-Macau Bridge is one of the most famous construction projects in recent history, and a big part of it involves an underwater tunnel.
China's newest mega bridge is open to the public. The 55-kilometer sea crossing connects the special administrative regions of Hong Kong.
That's been called one of the 7 wonders of the modern world. The tunnel itself is 6.7 kilometers long and sits 40 meters below sea level. But here's the thing, the ocean is full of water. So how do you build a tunnel down there? You can't just drill through the seabed like you would on land. The pressure is too high. The environment is too unstable. You need a completely different approach. At first, engineers thought about using tunnel boring machines, but those would have required going much deeper than necessary, which would have added time, cost, and risk. So they came up with a better solution, immersed tube technology. Here's how it works. First, you dig trenches on the seabed. Then, you build massive concrete tunnel sections on land, float them out to sea, and lower them into the trenches. Once they're in place, you connect them together and cover them with sand and gravel. Simple in theory, incredibly difficult in practice. Each tunnel section for the Hong Kong-Zhuhai-Macau Bridge is 180 meters long and weighs 76,000 tons. That's about the same weight as an aircraft carrier. And each section contains 2 3-lane roadways plus service tunnels. The engineers had to lower 33 of these massive sections into place, one by one, and connect them underwater with perfect alignment. But you can't just build a 180-meter, 76,000-ton piece of concrete in one go. It's too big. So the engineers divided each section into 8 smaller parts, built them in a factory, and then assembled them into the full 180-meter units before floating them out to sea. To make this happen, they built a massive factory on an uninhabited island called Niu 2. More than 3,000 workers put the factory together in just 100 days. Its only job was to produce 2 tunnel sections per month, and it did. For more than 1,400 days, the factory churned out sections using 330,000 tons of steel and 2 million tons of concrete. That's enough material to build 8 Burj Khalifas. The final section, called E30, was the last piece of the puzzle. It took 26 hours to lower it into place. Engineers monitored every detail from above, while divers worked on the seabed, making millimeter-level measurements to ensure everything lined up perfectly. When it finally did, the tunnel was complete, and the world took notice. What it all means. So what's the point of all this? Why does China keep building these massive, expensive, complicated projects? Is it just about showing off? Or is there something deeper going on? Some people online have compared China's rise to the way a person learns. You get smarter from both success and failure. You absorb information, you improve, you adapt. And that's exactly what China has been doing for the last few decades. They didn't invent most of these technologies. They learned them from other countries, improved them, and then pushed them further than anyone else thought possible. A lot of these projects aren't just for show. They serve real purposes. They connect communities. They boost economies. They make life better for millions of people. And yes, they also send a message to the rest of the world. China is back, and it's not slowing down. The economic benefits are real and measurable. When you build a bridge or tunnel that cuts travel time from hours to minutes, businesses respond. Companies set up operations in areas they previously ignored. Workers can live in one place and work in another without spending their entire day commuting. Goods move faster and cheaper. And all of that economic activity generates wealth, creates jobs, and improves living standards. Of course, not everyone sees it that way. Some critics point out the environmental costs, the land that gets cleared, the rivers that get dammed, the communities that get displaced. These are real concerns, and they deserve attention. Projects like the Three Gorges Dam displaced millions of people and changed the natural flow of the Yangtze River forever. And then there are the social costs, forced evictions, suppression of dissent, exploitation of workers. These are serious issues, and they shouldn't be ignored just because the engineering is impressive. But here's the thing. Whether you think these projects are amazing or alarming, you can't deny that they're changing the world. They're redefining what's possible. They're proving that geography, distance, and even the ocean itself don't have to be barriers anymore. From cross-sea bridges to undersea tunnels, from high-speed rail networks to water diversion projects, China keeps pushing the limits of what humans can build. These aren't just piles of steel and concrete. They're symbols of ambition, vision, and determination. They're proof that the future isn't something you wait for. It's something you build. So what do you think? Are China's mega projects a marvel of modern engineering, or do they come at too high a cost? Drop your thoughts in the comments below.